Alright, here we go. I said I wasn't going to do it, but I'm here. 4 videos in a row. It's almost 11 o'clock. All the Betty by children are put to bed. All the children are put to bed. Not all the Betty by, but the children. Alright, and basically we got a quiz coming up on permutations, combinations. And we're going to learn one more kind of just unusual, different way to use permutations and combinations. And then we're going to work through, we're just working through the sheet, giving you some examples. Quiz coming up here, not too long. And I'm coming back. Alright, so I know everybody's getting excited. Roll out the welcome papers. Here I come. Alright. So here's the scenario. There are 100 senators in U.S. Senate. 21 are females. 79 are male senators. Committee is to be formed using 7 people. Alright, so there's 7 people that are needed to form a committee. How many committees could be formed? Well, if I don't care about gender, I'm going to literally say, alright, first of all, is there any ranking in this committee? Alright, is there any order? Doesn't seem like it. I just need 7 people. So this is going to be a combination. I'm going to do combo. And I have a total of 100 people. I don't need to pay attention to males or females right now. And I need 7. That's your answer going to be for that. Alright, so it's going to be 100. Combination. 7. And this is going to be a large number. It's going to be a 1.6. And shoot, I'm just going to do a scientific notation. You guys can write it in the E if you want to write the E. I'm just going to go 10 to the 10th power. Alright. Basically. I could write, move the decimal over 10 times 2 as well. Alright, there's a lot of flipping ways to organize 7 people. How many committees could be formed if only females are selected? Alright, so this is kind of like given now. It's almost like knowing there are only females, how many committees. So we don't care about the males. We're only looking at the females. And so we got to look at the total females, and there's 21. So now instead of 100, I'm only looking at 21, and it's still going to be C, 7, because the order doesn't matter. And there, that's going to be your answer. Not too bad, right? We're cooking with gas. 21. C7. And I got about 1, 6, or... Oh man, that doesn't even look like a 6. Kinda. Maybe now. Alright. 2, 8, 0. Alright. How many committees could be formed only males are selected? Well, I don't care about the females now. So, it's going to be a combination. Not out of 100. I'm only caring about 79. And I want 7 people. So, it's going to be combination, or 79, combination 7. Super easy. Super easy. There's going to be a lot more. It's going to be like 2, 8, 9. Oh my goodness. You're going to make me do this, aren't you? You're going to make me write the whole thing out. Because you're going to be like, well, what's the final answer? 5, 3, 7, 1. And there's one more digit. I'm not telling you. You've got to figure it out. What's the missing digit? Alright. You got to do it yourself. Alright. How many committees could be formed of 4 females and 3 males? Alright. And here is the new question of the day, really. Alright. So, you kind of got to split it up. So, let's just take the females on. So, I don't care the order of females, so it's going to be a combination for females. And how many females are there? There's 21. And I want 4 to be female. So I'm going to do combination 4. Alright? So it's kind of like 2 different problems. Then the males, I'm going to have a combination. How many males are there? There's 79. All right, and we want 3 of those. Now, once I get these answers, I'm probably not going to write. It just takes me too much time to write down the answers right now. But once I get these answers, what do you think I'm going to do? Okay, if there's this many ways I can organize females, and there's this many ways I can organize males, will I multiply these two answers or will I add them? Think about it. Well, if this is the way the females can happen and this is the way the males can happen, if I multiply those, it's gonna be astronomically larger than it's possible. It's adding. And basically say, hey, listen, if this is how many females can happen, this is how many males can happen. I think. So, as I started explaining, I was like, I'm not explaining this right. It's multiply, guys. My bad. And I want to kind of tell you this. For instance, let's say we have, and I'm going to be way off. Let's just say that this number here is like 12. Okay, so there's 12 ways to organize a girls group. And how many ways can we organize a men's group? Let's say there's 15. I know, way off, not even close. These are going to be massive numbers. I don't want to play with massive numbers. There's 12 ways to organize a girl, right? Well, that would line up with one way of the men. So with just one way of the men and 12 of the girls, that would be 12. Well, then there's another 12 for every different way a guy can line up. So it is going to be multiply. My bad. Did I say it's late? Man. Whew. Okay, so you're going to end up multiplying those two together. So you're going to get some kind of crazy answer. I'm going to pause it and tell you what kind of crazy answer you're going to get when you multiply the two together. All right, so if you multiply them together, you get this massive number. This is how many ways it can happen. All right, moving along. We're going to hopefully get through this. There are 20 hockey players on a pro NHL team, 2 of which are goalies. How many different ways can 5 skaters and 1 goalie be on the ice at the same time? All right, so we're going to kind of separate these. Have our skaters, have our goalies. Okay, so they're going to be kind of separate problems, then we'll multiply them together at the end. So how many ways can skaters be? So first of all, does it matter the order the skaters are in? I don't think so. Okay, it's just that the 5 skaters are out there on the ice. So this is going to be a combination again. But instead of 20 hockey players, it says there's 20 hockey players, 2 of which are goalies. So my skaters are not out of 20. It's actually out of 18. So I have 18 skaters because 2 are goalies, not 20, right? And I want to know how many ways I can rearrange 5 of them, 5 of the skaters. And then I'm going to have a separate problem. Remember, I'm going to multiply these together. I'll never make that mistake again. Whew. Okay. With how many ways goalies can happen. And there are 2 goalies, and I want to know how many ways I can rearrange one of them. I'll give you a hint. It's 2. Okay, there's only 2 ways that can happen. All right, when you multiply that together, and I'm learning a new tool here. I'm just going to do this so I don't have to manually write it all out. It didn't. I think if I did everything right, it's that. Okay. Alright. There's that many ways we can rearrange skaters on the ice. License plate has 3 letters followed by 3 digits. How many license plates can be made if there are no restrictions on the letters or digits? Alright, so does order matter? Let me think about this for a second. Alright, they almost tricked me on this one. This isn't a permutation or a combination because we can have repeated numbers. And so basically, this one's a little tricky. Man, they really throw this out there. Alright, so 3 letters followed by 3 digits. Alright, so this is like fundamental counting principle. Alright, all it is basically how many letters could the first one be? And there are how many letters in the alphabet, ladies and gentlemen? Well, shall we Google? How many letters in the alphabet? 26, just like cards. It's not that hard to Google, guys. Alright, so there's 26 possibilities for the first. I could have like all A's here, right? A. So I'm not losing a possibility here. Right? I'm not losing people. Like when we were talking about people on first and second place, you know, I'd lose one. And then there's 26 possibilities here. Alright? Now this is followed by 3 digits. Well, how many digits do we have? We are a 10-digit society, ladies and gentlemen. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's 10 digits. Don't include 10. 0 to 9 is 10 digits. So it could be anything from 0 to 9, and that's 10. Oh boy, I might be able to finish this problem. Alright, and this is the fundamental counting principle. I'm just going to multiply these puppies together, and I got my answer. 17. You need to pause the video. 17,576,000. Okay. All right. Now here's the one we're gonna done. I think. Okay. How many license plates can be made if no digit or letter may be repeated? All right. So first of all, doesn't matter the order on a license plate. Okay. Doesn't matter order on a license plate, and I would have to say yes, it does. The first digit matters. Okay, and then the second digit matters. So I know many of you guys have always thought this is a combination, but order does matter, so it's a permutation. So we're going to split this into 2 different permutations. We're going to do permutations for the alphabet. So there's 26 possible answers for the first digit. How many ways can I have? 3. All right. Okay, and then I'm going to multiply that with the permutations of the digits. And there are 10 digits, and I want 3. So it's the same as this up here. I'm doing 2 separate because I've got my letters and then I've got my digits. And I can't have repeats, so you know there will be 26, then there'll be 25 and 24. Okay, so you can do this. Let's do this quick. 26. Forgive me. I don't feel like pausing it. Alright. I got an answer. It is 112320000. Alright, that's what I got. That's how many ways you can do a license plate. Which kind of makes you think. There's got to be more cars than that out on the road. Oh, from every state. You think there's 11 million from every state? Because every state has a different license plate. I don't know. Okay. Well, you guys got the rest. You can just shimmy on, try your best through. Quiz is coming up. I'll be back tomorrow. Come with questions, and I'm going to bed. Bye, guys.